Right, we're going to look at how we simplify algebraic fractions. So we've got a sheet with these questions on that I'm going to go through one by one. Be aware of the difference between when expressions are being multiplied together, like these ones, top and bottom, and when they've got pluses and minuses. You can only cancel top and bottom when you've got common factors in every single term. And if it's being multiplied, then 5 is a common factor. 5 is a factor, 30 is a factor. So I've got a common factor of 5 I can cancel down. I can divide both by 5 there. I can cancel out the d squareds. I can cancel out one of the e's to give me 1 over 6e squared, which is what you had before. I can't cancel x squared there. I can't cancel bits of fractions. It's a bit like saying, let's rewrite 4 or 5 as 3 plus 1 over 3 plus 2, and because a 3 appears somewhere in the top and in the bottom, I can cancel it and say that 4/5 is exactly the same as a half. It's not. It doesn't work like that. The 3 is not a common factor. I can't do it. What I have to do in this case here is factorise a thing. And then when I write it as something times something else, I've got factors there. And if one of these brackets appears in the bottom as well, I can then cancel it out because it's a common factor. So I've got x plus 3, x minus 3. And I'm hoping that one of those is going to be a factor here. And x squared minus 9x plus 18 is x minus 6 times x minus 3. That gives you the minus 9, and that times that is a plus 18. And they cancel out because they are common factors to leave me with x plus 3 over x minus 6. Similarly with this one here, I can take out number common factors and letter common factors and do bracket times bracket as well and see what I've got. So the 6 and the 15 have got a common factor of 3. X squared and x have got a common factor of x. I can write that then as 2x minus 5. And then here I've got a number common factor of 6. So 2x squared minus 3x and then minus 5. I'm hopeful that the 3x, 2x minus 5, got the 6 there, don't forget, and I want the 2x minus 5 hopefully to be that one there. And let's have a look. If I do x plus 1, does that do the job? Plus 2 minus 5 and minus 3 of them, yes it does. They cancel out and 3 over 6 becomes 1 over 2, so I'm left with x over 2, x plus 1. That's it. So I can cancel because the bracket is a common factor to the top and the bottom. Okay. Example 2, when it's fraction times fraction, exactly the same thing. What I don't want you to do is times it all out and then look to cancel down. Your thought process can be, if you rearrange things that are going to be potentially cancelling down, like the 10 and the 25, and then I've got times 9 times a squared times b on the top. On the bottom I can have times by the 3 there and then times by the b squared there, and do each bit separately. What does 10 over 25 equal? It equals 2 over 5. And then times 3 times a squared, oops, and hopefully I'm just about okay because the 9's cancelled down to give me the 3 there, and that's gone there, and leaves me with just the b on the bottom. The 3's cancelled out, the 10 over 25 is cancelled down, and leave one left with 6a squared over 5b. Okay, don't make your numbers bigger to then cancel down to make them smaller, because you're multiplying. I know it's a calculator paper, but even so, you're dealing with big things. The issue with cancelling across fractions like this, which you can do because it's that times that over that times that, is just being aware of what's gone on, what's cancelled from where, and what you're left with. You make sure your presentation does the job. And similarly for this one, I can think about this fraction as being 4x squared minus 9 over 2x minus 3, because that's going to be cancelling down, times by the x squared plus x over x squared plus 2x plus 1. And that equals 4x squared minus 9, difference 2 squares, 2x minus 3, 2x plus 3, and then times by x bracket x plus 1, squeeze it in. Then I've got the 2x minus 3 on the bottom, cancel because it's a common factor, times by x plus 1 all squared on the bottom there, and that bracket and that cancel out because it's that times that times that times that. I can cancel brackets that appear in the top and the bottom. If it was a plus or a minus in between, I couldn't do because it's not a common factor. I'm left with, let's be careful, x bracket 2x plus 3 on the top over x plus 1 on the bottom. Just remember as well, what's not in this question here and this working here is the fact that your division line is a hidden bracket. It actually means that and that. So I don't have to put the bracket there, but it's there. Just be aware of that. A third example, you started off okay because it's a division question and you use keep change flip, so it equals 12 over the x cubed minus x. Keep that, change that to times and flip that, x plus 1 over 4, and my thought process becomes I can think about the 12 over 4 and then times the x plus 1 over x cubed minus x. And 12 over 4 gives me 3 times x plus 1 over x bracket x squared minus 1, 3 bracket x plus 1 over x bracket x plus 1 x minus 1, difference 2 squared in the bottom now because I've taken the x out. Bracket cancels, 3 over x bracket x minus 1. I can cancel the brackets again because it's a common factor, because it's that times that times that. 1. Okay, example 4a, subtracting, adding fractions, you need a common denominator, preferably the lowest common denominator. So in this case here, the second fraction can be thought about, and be careful with that minus there, realise and remember it's that bracketed expression there. I'm hoping that I get a plus 2 because that's the denominator of the other one, and then 2a something or other, probably minus 3 to give me the minus 6. Let's have a check. Plus 4a minus 3a is plus a, so we're good to go. Now, what it means for this fraction over here, I need to rewrite it. It's a bit like doing a subtraction of 3/4 minus a half, where I can put them both over 8 by times and then cross multiplying, but if I keep one of them the same, I just need to make sure that the other denominator is the same as the first one by changing it. In the same sort of way, if I want this denominator here not to be a plus 2, but a plus 2 times 2a minus 3, I need to get what it was and multiply it by 2a minus 3. I now have the same denominator, so I can then just concentrate really on the top. So I've got the 2a minus 3 there, and then times it all out. So 2 times 2a minus 3, 4a minus 6, minus. Be aware of that. And that's why they put that in, to create that potential problem there. Okay? So a lot of people would write minus a minus 2, but we realise because of that bracketed expression, that hidden bracket, we end up with a plus 2 there, and that's where people's errors are going to come. And 4a minus 1a, 3a, minus 6 plus 2, minus 4, and then over a plus 2, 2a minus 3. Okay, and similarly, last example, where you've got different denominators, nothing in common, that is the ones where I'm just going to end up cross multiplying and then times on the bottom. So for the first fraction to have that denominator, I need to multiply the 3 by the x plus 1. For the second fraction, which are already over x plus 1, to have this denominator, I need to multiply the 4 by the x minus 2. So it is your typical times at the bottom, cross multiply. So it's, if I've got 2 times 7 there, plus 1 times 3, all over 3 times 7 times at the bottom, and then cross multiply. That's your typical, because there's nothing in common on the bottom. And then just ties it all out and tie it all up. So 3x plus 3 plus 4x minus 8 all over your brackets equals whatever it does, 7x plus 3 minus 8 minus 5 over x minus 2, x plus 1. And that's it. Always look to do a factorised version on the bottom if you can, because there's the potential that what you get on the top could cancel out with something on the bottom. It hasn't done any of these examples so far, but it could do at some stage in the future.